Hey guys, Miss G here. We are starting a new unit. This unit is called kinetics. Kinetics, as you know, it's related to motion or movement. So, particularly in chemistry, we're talking about the movement or motion of chemical particles. So, we're going to start off with the collision theory. In order for any reaction to occur, the reactants first need to collide with each other. And not only do they have to collide, they have to collide with enough energy, which we call them activation energy, or we'll talk more about it for the next couple of days. And they need to have the correct orientation. What do I mean by the correct orientation is I always think about Legos. If you play with Legos, you always need to put them in the right orientation for them to fit. So same with molecules for any substance. When they collide at the right orientation, they will react. And there are a couple factors that affect how fast a reaction can occur. So the three things that we will discover or will investigate in this upcoming lab is concentration and temperature. We're going to start this unit with a lab reaction between HCl and sodium thiosulfate. If you haven't watched any of these two videos, please go back and watch these two first. You will need to see how this reaction occurs first before we move on. If you did see how thiosulfate and HCl will react, then you can keep on going. All right. If you already watched the video, you can tell if when HCl and thiosulfate react, they will not react immediately. It takes a while for them to actually react. And once they react, they will become a white cloudy solution. So we have two reactants, HCl and thiosulfate, or sodium thiosulfate. But the sodium part, we don't really care about it because it will just end up in sodium chloride, which we know they kind of like just free-flowing ions in the solution. What makes the solution cloudy after they finally reacted is the product, the sulfur. So the sulfur is a solid. We know when it precipitates, it will form this white cloudy-ish solution. So students from last year actually did this lab and collected some data on this. So there are three things that they changed, but they didn't change it all at once. They changed it for each different things that they're looking for. So they changed the concentration of HCl, they changed the concentration of thiosulfate, and also some of them changed the temperature. So for the concentration change, students, they will actually change the amount of solution they added. And in order for calculation to go easy for them, they kept the total volume in the beaker, in the mixture, where the reaction occurs the same. So it's 55 milliliters throughout the entire experiment. And for temperature change, some students, they either cool it down by putting the reactants in ice water bath, or they kind of warm it up with hot water bath before they mix them. The most complicated part about this lab is, I think, is when you calculate the concentration. As we know, when you have separate reactants, they don't react. So we don't really care about their concentration before. What we care about is their concentration during reaction. So we're going to continue use this formula called M1V1 equals M2V2. And if we look at from the previous year data, this right here is the control experiment. So this is the control, and then they will change their volume used or their temperature according to the control. So for this control, the students used 30 milliliter of thiosulfate, 5 milliliter of HCl, and in order for this the volume of the final mixture to be 55, they had to add 20 milliliter of water. Let me just explain more how you can calculate the concentration. So if we're changing the concentration of HCl, what we need to keep constant is thiosulfate. The only volume we're changing is HCl. So we only have to calculate thiosulfate concentration once. And then we'll have to calculate HCl concentration for all these 6 experiments. Let's do the control one first. So control, if we look at the things we're going to put together in this final mixture, which is in this kind of like a beaker in the middle, we're going to keep them at 55 milliliter. If we add 5 milliliter of HCl and 30 milliliters of thiosulfate in here, and plus 20 more milliliter of water, this final mixture concentration is what we care about. So the second V2, if we look at the equation, and when V1 equals M2 V2, this V2 right here is always going to be 55 milliliter. This is the final volume of the mixture that we care about. And then we'll use this volume to calculate the concentration. If we look at the control, we're starting with 0.15 molar thiosulfate and 1 molar HCl. So this is given to you. You can't change it. This is the starting molarity. For the control experiment, we added 30 milliliters of thiosulfate, 5 milliliter of HCl, and 20 milliliter of water. So in order to calculate the new concentration, the concentration in which the reaction occurs is we need to take the original molarity of thiosulfate, which is 0.15 molar, multiplied by the volume we're going to use, which is 30 milliliter. And that equals to M2. M2 is the one we're trying to find. It's the new concentration in which the reaction occurs. And then V2 is going to be 55 milliliter. It's the total volume of the mixture that we have at the end during a reaction. So remember, V2 is going to stay the same throughout the entire experiment. It's always 55 milliliter. For the new concentration of HCl, we're going to use the starting molarity, which is 1 molar HCl. So 1 times the volume, we use 5 milliliter. So we multiply by 5 milliliter equals to M2 is what we're trying to find. And then V2 again is always 55 milliliter. And then these are supposed to be your final concentration during reaction. Again, we only care about the concentration during reaction because that's when we're trying to investigate how different concentration will affect how things will react. All right, so here are the data for the changing concentration of HCl. I just showed you how you could calculate the control and see how if we're changing the concentration of HCl, after you calculate the concentration of thiosulfate, they should stay the same. The only thing that is changing should be the concentration of HCl. So take your time to calculate for experiment 4, 5, and 6, the concentration of HCl. And once you are done with that, you may check your answer with the next page. So here's the answer for next page. For my class, I don't know for Mrs. Berker's class, but for experiment 6, please submit your answer to Canvas. And here's the changing concentration for thiosulfate, same thing. Now instead of changing the concentration of HCl, we're going to change the concentration of thiosulfate. And in order to change the concentration, the only thing that we're changing is the volume of thiosulfate. And please calculate for experiment 4, 5, and 6, the concentration for thiosulfate. And for my class, please submit experiment number 5 to Canvas. And I think, right here, this is a changing in temperature. So temperature, we're keeping the concentration all the same for thiosulfate and hydrochloric acid. The only thing that is changing is the temperature. All right, that's it for the intro for Thiosulfate Lab.